Okay, so welcome to geometry. Let's start off by talking about the father of geometry, the guy who started it all. So this is Euclid. Everyone say hi, Euclid. Hi. He lived a long time ago. He lived like 2,300 years ago. So when's that? That's like BC. That's like before year zero. He lived a very long time ago. Him and his colleagues were discovering lots of things about the world, about geometry, about math in general. And what they did was they compiled all of those thoughts. They wrote them down or wrote them on tablets, or I don't know what they had back then. But they did compile them all together in a book, but not a book like we think of one today. And they called it the Elements, Euclid's Elements. It's like an alliteration, and those start with an E. The way you spell his name, Euclid. So they wrote the Elements, and honestly, a lot of what they came up with and wrote has not changed all the way until today. What they started with when they were discussing was they started with this, right there. What is that called? What did they call it when we translate it to English? What is that? There's a P. Point. It all started with a point. A point is the most rudimentary, basic symbol that we can have, and it started everything. So they started with a point. A point's a location in space. Then they said, hey, well, what if I draw another point? And then, ooh, what if I connected them? So then they're like, oh, they just added on. I'll connect those points. Da-da-da-da. And what did they dream up? What did they come up with when they connected those points? Not that one, a line. We'll talk about what that is in a minute. A line. The point, and then born was line. Line was the next thing born. Then they're like, well, let's just keep going. What if we put another point, and then somehow, I mean, I could draw another line, but now I just have two lines. That's not exciting. Somehow, how could I join all three of those points forever and ever in all directions? Well, if I tried to kind of connect those points, and I kept going forever in all directions, and I held on to all of those points, I would have this flat surface. I would have a plane. So those are the three, what we call undefined terms in geometry. The three most basic building blocks that all other geometric objects are built upon. Point, line, and plane. We call them the three undefined terms. So, if you did have your vocab, we're going to skip charades, sorry. If you did have your vocab, you would get that out at this time. It looks like this. It's on the calendar. And we're going to go by word, one at a time. The first word on your vocab sheet is point. It's a location in space. It has no thickness. Can you measure a point? Not a geometric point. Maybe you can measure a dot. If it's, you could have thin dots and thick dots, right? But for our purposes, a point has no dimension. It's like zero-dimensional. It's just a location in space. It looks like that. And we name it all the time, every time. We name it with one capital letter. So I would call that point P. Capital letter P. How do we name a point? A capital letter. One letter for 1 point. Next word. Line. A line, your textbook defines it as a connected straight path. I might not pick that one, but it just means what a line is it's a series of points that extends in opposite directions forever and ever and ever. And if you collect all of those points, collect all of them that exist in two directions, in two or both directions, you get a line. So how many points does a line contain? How many points does a line contain? Good word. It contains an infinite number of points. That symbol means infinity, infinite. Okay? It does go on forever. It does go on forever, and the way we show that is by putting arrows on it. So a line better have 2 arrows because it's indicating it goes on forever in 2 directions. How do we name a line? Well, you pick any 2 points on the line. Remember, there's an infinite number of points. You pick any 2 points. You write them with capital letters, and you put a line symbol on top. So that is saying line AB. Now, of course, they're going to try to trick you. Not really try to trick you, but there's another way to name a line as well. For example, sometimes I'm Mrs. Tanton. Sometimes I'm Amanda. And sometimes I'm Mommy. I'm Mommy a lot at home. Anyways, I can name this line different ways for different occasions. So I could also name it line lowercase cursive letter, line L, or line, you could do lowercase italicized M. You get the idea, okay? Lowercase. So I could call it line AB, I could call it line L. By the way, they can trade places. I could also call it line BA. That is totally legal, and it's the exact same line. Order doesn't matter. Okay. This is really important. I want you to stare at this. I want you to read that question, and I want you to think about the answer. All right. Is line AB, see how I put that word line in because I saw that symbol? I'm translating math to English. Is line AB the same as line CA? So, line AB means it's a connected straight path through A and through B. And how far does it go? Well, it goes on forever. Okay. Forever. Keep going. Going. All right. That green one is line AB. Got it. The green one. Okay. Now I want to look at, is it the same as line CA? So pretend, I'm not going to put it right on top. I'm going to put it right here. CA. Now a line is a connected straight path. Okay. So I'm going to connect these. And I'm going to go on forever and ever. And it keeps going forever and ever and ever and ever. Is the green line the same line as the blue line? Yes, so really important. AB is not different than CA just because I use different letters. They're not different. What else could we name it? I can pick any 2 letters I want. We can name it BC. We can name it BA. We can name it AC. You see how I'm just switching the order of the letters? So we could name this line so far at least 5 ways. We could name it 5 ways. Okay? Same line. They're all talking about the same line. Let's move on. Plane. A plane is a flat surface. It has no thickness. You can't measure how thick it is because it doesn't have a thickness. And it extends forever in 2 directions? No. It extends forever in all directions. What I want you to understand is that a plane doesn't have edges. In that picture, does it have edges? Yeah, it looks like a parallelogram. That's because it's hard to draw something that's infinite on a finite space. It's hard to draw it on a Smart Notebook slide or on your notes. So just remember, I don't draw these arrows every time, but please remember that this keeps going. This plane does not have edges. It continues forever in all directions. Now, how do we name a plane? Get in the way. We can name it plane R because there's an italicized R in the corner. It's really important that it needs to be kind of cursive italicized. You can name it plane R. But most often, we're going to name it with 3 capital letters. 3 points in the plane. X, Y, Z. Plane, X, Y, Z. 3 points in the plane. So notice, we name a point with 1 capital letter. We name a line with 2 capital letters. And we name a plane with 3 capital letters. Numerical order. You just add on each time. We're not going into 4 points, I promise. Okay. Let's see what's next. Okay, the next word is segment. Segments like you take a line, and you chop off the arrows. Chop, chop. You chop off the arrows, and the distance in between there all the points between C and D on that line become the segment. That is a segment. Oh, I chose the right letters. Score. So a segment is a portion of a line. A segment is part of a line. A line is not part of a segment. Be careful there. Notation, capital C, capital D, segment on top. Arrows do not go on segments. 0 arrows. How many points are contained in a segment? How many points are contained in a segment? I want you to remember that even though a line goes on forever and a segment doesn't, in between C and D, how many points are there? Well, let me start drawing some. I just drew 10 points. Did I catch all of them? Is that all the points? Do points have a thickness? They don't have a thickness. That means I could keep squeezing in more points and more points and more points, and I could stay here for the rest of my life putting more points. They don't have a thickness. The points don't take up space. So what I'm trying to tell you is, even though a segment doesn't go on forever, there's still an infinite number of points contained in the segment. If you said infinite, you were correct. Is your mind blown yet? Okay, next word. Next word is ray. When I think of a ray, I just think of sunshine. It makes me happy. Let's think about what the sun is. The sun is a big ball of fire, right? And then out of that big ball of fire, light shoots out in all directions. It's really cool. So I want you to think of a ray as a big ball of fire with I can't use the word ray in the definition, but a ray of light shooting out of it. So a ray is going to have an end point, like the sun is the end point, and then it's going to continue forever because the rays from the sun go on forever. That's why a ray of sunlight is a great example. It goes on forever in one direction. So there's our, where are you? There's our picture of the ray, and that's how we name the ray. Now I want everyone to listen. I want you to put a star if you have these notes out. If not, you need to add to it later. When you're naming a line, the order doesn't matter. When you're naming a segment, the order doesn't matter. When you're naming a plane, the order doesn't matter. When you're naming a ray, the order matters. It's really the only time here. That is not ray QP. Why not? Who cares which letter goes first? So right now that ray is going what? Northeast. But if I name it ray QP, then my ray is headed southwest. Those aren't the same ray. That green one and that brown one are two different rays. Okay? So the order matters, and the end point must come first. The end point must be named first. So, what's the name of that ray? QR. You have to name the end point first. Okay? Opposite rays are the next thing. There's no notation for it, so sorry, that box should be empty. Opposite rays are the next thing on your vocab sheet. Whoa, there's a lot of words in this definition. Collinear rays. Well, wait, Miss Tanner, we haven't gone over collinear yet, so just put that on the back burner. With the same endpoint. You and your friend get in a fight, or let's say you and your sibling, because that probably happens more often. You and your sibling get in a fight, and you're so mad at each other. Here you are, here's your sibling. You're so mad at each other. You walk this way as far as you can, and your sibling walks this way as far as they can. As long as you're going in opposite directions, get it? Opposite rays. As long as you're going in opposite directions, then you would represent opposite rays. So in this picture, what are the opposite rays? YZ and YX. Those are opposite rays. Now what do you notice those have in common when I named those? The Y. Because they have the same endpoint. So they better both start with the same letter. And what do opposite opposite rays always form when you put them together. With our powers combined, we will form, yes, very good, a line. I'm sorry I'm being goofy. These notes are so boring. I have to do something to spice them up. Okay. Here's that word that was on the other slide. You can kind of see it. It's about to reveal this. Okay. Collinear. I want you to say that out loud. Collinear. Pretend I heard you from all the way at Cy Falls. Okay. Collinear. I want you to think of co means same. Like a co-worker works in the same building, same company. Co means same, and linear means line. Collinear, same line. Points that lie on the same line. Points A, B, and C are collinear. They lie on the same line. Okay. Now, what I want to contrast that with, let's just draw some. All right, good old alphabet. Name me 3 collinear points. Name me 3 collinear points. Okay, so someone said B, D, F. Let's pretend I was perfect. Please, please, please be perfect. Oh, that's not too bad. Collinear means there exists a line through all of those points. Does there exist a line through B, D, F? Yeah, I just drew it. What about ADE? Are those points collinear? Can I draw a line through those 2 points? Is that a line? No. A line is a connected, straight path. So that is not a line. So what vocab word would I use for ADE? What would be the opposite of collinear? That's kind of silly. It'd be, oops, I wrote it twice. It would be non-collinear. So that's the next one. Points that do not lie on the same line. I could not draw a line through A, B, and C all at the same time. I couldn't catch all 3 of them without curving, and lines don't curve. Next word. Coplanar. What do you think that means? Co is same, and then planar implies a plane. Coplanar, same plane. Points are lines in the same plane. We've got a couple planes here. We've got plane R. I'm going to use the italicized way to name it. And we've got plane P. Okay? Let's name some coplanar points on plane R. Name me some points that are coplanar on plane R. E, H, I, F. You see all of those that are contained in plane R? Those are coplanar. What about some points in plane P? C, H, I, D. Okay, so coplanar, same plane. Non-coplanar, points that do not lie in the same plane. Let me give you an example of non-coplanar points. E, C, H, I. If I took all 4 of those points, there does not exist a plane that could go through all 4 of those without bending. Planes also cannot bend. They're a flat surface. So those 4 points would be non-coplanar. We'll talk more tomorrow about coplanar. Coplanarity. I'll have to work on that word. All right. Let's do some examples. Name line M another way. So, to name a point, 1 letter. To name a line, 2 letters. To name a plane, 3 letters. So I can take any 2 letters on this line, and I need to use the correct notation, line JP, line PJ, pajamas. Okay? That's how I'm naming it another way. Name the point that lies both on line N and line K. The point that lies on both line N and line K. How do you name a point? Ooh, be careful. 1 capital letter. Am I going to be picky about that? Yes. I'm not picky about things that aren't important, but that's important. Name the line that contains point A and point E. Name the line. Oops, I got rid of point A from my picture. I'm sorry. Make this J. Name the line that contains point J and point E. Is that a trick question? There is no line. Y'all are good. Y'all are good. Just because, this is so important, just because a line is not drawn doesn't mean it doesn't exist. There does exist a line. There exists a line through J and through E. It's not drawn, but it's there, and I can call it JE or I can call it EJ. That line does exist, and I can name it because I know 2 points on the line, and I can name it. I've got the power to name that line. Okay, let's look at coplanarity. Points U, X, and W are coplanar. True or false? Oh yeah, they are. That's true. Now, I want you to name the plane that they're in. Ooh, wait, how do we name a plane? I don't see any italicized letters, so you can't do one italicized letter. You need to pick 3 points in the plane. Could I name the plane that they're in U, V, W? Could I name it that, even though V wasn't one of the points? Doesn't it go on forever? Will it catch that point eventually as it goes on forever? Yeah. So I can pick any 3 points, and I can name it. I do not put commas between them. I am not listing points. I'm not listing points. I'm naming a plane. And that looks weird. Let's pick X, U, W. Any 3 points. Okay, next one. Points Q, R, and W are coplanar. Q, R, and W. I want to remind you. Are points A and B collinear? Are points A and B on the same line? Yes. Is the line drawn? Nope, the line's not there. But could I draw a line through it? Sure could. Yes, ma'am. They are collinear. Now let's go back to this. Q, R, W. Is a plane drawn that goes through those 3 points? I agree with you. No. The plane is not there in the picture. But, wait a minute, could I? Oh my goodness. Does there exist a flat surface that can go through all 3 of those points? I'm cheating. I'm going diagonally through the prism. Yes. So it was actually true. Just because something isn't drawn doesn't mean it doesn't exist. Don't get frustrated. It'll sink in, I promise. We're going to move on. We're going to finish the vocab sheet because I know some of you need to go. Next word, parallel lines. You've seen this word before, lines in the same plane that do not intersect. These arrows are how I tell you that those lines are parallel. So if you just see 2 random lines on a page, right now, and I threw that one a little weird. Right now, we cannot assume those are parallel. You would have to see this symbol on them, and then you're like, oh, okay, now I can confirm they're parallel. We never assume they're parallel unless they have that little symbol on them. Let's see. The symbol for parallel, it was in the warm-up today. It looks like that. And we're going to move on. The next word is more important because it's newer. The word is skew. Say that out loud. Skew. Okay. So, skew lines are very similar to parallel lines. I mean, just take a look at the definition. Parallel lines, lines in the same plane that do not intersect. Skew lines, lines that are not coplanar and do not intersect. So the only difference is whether they're in the same plane or not. Let me show you what's going on here. These two, can you see them? Parallel, skew. There we go. Parallel, going the same direction, skew. I'm going to do my arms because the camera isn't picking that up very well. Parallel, skew. It's like I'm karate chopping. Parallel, skew. So what do they have in common? Parallel and skew, they both never intersect for all of eternity. What's different about them? Same plane, different planes. Same plane, different planes. Parallel, skew. Okay, so look at A and B. Those are not in the same plane. They will never meet up. B is behind A. They will never meet up. That is skew line. Congruent segment. You probably already know what congruent is. That is the symbol for congruent, and it means they're the same length. We usually put tick marks on segments to show that they're the same length. Those are called tick marks. Congruent segments, same length. That's the symbol we use for congruent. Midpoint, we're going to get into this next unit a lot more. A point that cuts a segment in half. That's all I'm going to say about that. For right now, all you have to know is the definition. We're going to dive deeper into midpoint later. Midpoint, middle. Midpoint, middle. Bisector, we're also going to dive into a little bit more next unit, but it's on this vocab sheet. A bisector is a line rayur segment that cuts a segment in half. So a bisector cuts in half. It's on your vocab sheet, but don't worry too much about it yet. And then the last one is space. It's this very, very abstract concept. It's the set of all points in all of eternity. There is no picture for it, and there is no notation for it. It's just, we want you to know the word space. All points. There's that right. Okay, last thing of the day is we need to go over notation a little bit, okay? When you put two capital letters and you put a segment on top, this is an object. It is a segment. It's a segment. It's an object. When you don't put a segment on top, it is a length. It is a distance. Now, if I just said, hi, I'm Miss Tanton. I'm 20, oh no, that would be my years. Okay, hi, here's a rod, it's 5. Well, what do you mean it's 5? Are you measuring its length? Are you measuring its weight? Are you measuring its thickness? A segment can't be 5. Can the length of a segment be 5? Yes. But it, as an object, you can't give an object a number because you're not indicating what about that object you're trying to describe. So objects don't get numbers, but lengths and distances absolutely get numbers. So let me talk about what that means. Let's look at all the good ones first. These are good. We like these. The distance from A to B equals 2. Equal sign, this equal sign, that goes with numbers. You're only allowed to use an equal sign if you're working with numbers. AB equals 2. That's good. The distance from A to B is 2. Look at the next one. AB equals AC. That's awesome. The distance from A to B, the distance from A to B equals the distance from A to C. We like that. Distances can equal each other. The last one. Segment AB is congruent to segment AC. So we use equals with numbers and we use congruent with, I'm going to call it objects or symbols. Okay? Segments can be congruent and lengths can be equal. Let's talk about why the bad ones are bad. A segment equals 2. That's like me saying, my desk is 5. Well, your desk is 5. What does that mean? Okay? A segment cannot equal 2. Bad. A segment equals a segment. Well, you're not allowed to use an equal sign with objects. So that's bad. A distance is congruent to a distance. Wait a minute, the wrong symbol is there. It should have been an equal sign. Hope that makes sense. All right, before you leave, we're going to play this quick I Spy game, and then our lesson is over. translators. I want you to look at number 1, and I want you to say it out loud to yourself. That's math language up there. It's not English. You can't write that on an English paper and turn it in. But in math, we use symbols more than we use words. Because mathematicians are quite lazy, actually. Okay, number 1. Say it to yourself. Hopefully you're saying line empty. That is line empty. That's how you say it in English. Let's skip number 2 for a minute. Number 3, say it to yourself. Ray XY. That's the English. Ray XY. Number 4. Segment HV. Do you see how all of these change just because of these little arrows? These arrows, or lack of arrows, tell us what object it is. Next one. What is just a capital letter by itself? What is it? Oh, it's a point. Point A. All right. What about a lowercase italicized M? That's another way to write a line. Remember, we can write it with 2 letters or a lowercase italicized letter. That will be in your notes. Ooh, number 7. That's a whole sentence. It's not just a word. Let's read number 7. Line, GH, is parallel to line IJ. You see how I put all of those words into that little symbol? Pretty cool. We get to be pretty lazy. Number 8. Segment OK is congruent to segment RA. And number 9. Line ME is perpendicular to line YU. And we'll deal with perpendicularity next unit.